Hello, calculus student. This video is for chapter 3.7, part 2, derivative of an inverse function. In the last video, we did a derivative of inverse trig functions. And so here's the formulas. Let me make it a little bigger so you can see it a little easier. So the derivative of inverse of x is 1 over square root of 1 minus x squared. Derivative of the inverse of cosine is -1 over square root of 1 minus x squared. And talking about this, in the last video, I did a 3.7 part 1. When I do example 2, 3 arc cosine x over 2, I forgot to put -1 here. So I just say 1 over square root of 1 minus x over 2 squared. That is sine. For cosine, there is a negative. So I should put the -1 back. Okay, so that was the last from the last video. So this should be a negative. Okay, should be a negative. Okay, so the next page is the following page is more example. So I should adjust it. So this is the y equal to 1 plus arctangent x cubed. And I want to find a derivative of this. So did you notice that this is a inside-outside function? It is a composite function that require chain rule, although our arctangent is inside. So what we should do is look at this whole thing as the inside function, and this is the outside, and do a derivative of it. So I'm going to do the steps here. Okay. Oh, do the steps here. We would say dy dx of this would equal to the dx of this inside the outside cube. So use the general power rule of 3, 1 plus, so let's say this is inside function. And the outside is a cube. So use the general power rule would be 1 plus arctangent inverse, just copy the whole thing, but square, because it's as if I'm doing u cube derivative. So it would be 3u squared times d dx of the whole inside. 1 plus arctangent or tangent inverse x. Okay, so this would just stay as that. 1 plus, there's nothing you can simplify. This is still square. But for this one, when I do a derivative of 1 is 0. When I do a derivative of this, it becomes 1 over 1 plus x squared. So you multiply this two. So this is the top and this is the denominator. So it'll be 3, 1 plus arctangent inverse x squared over 1 plus x squared. And that's the answer for 4. So for 5, let's use the space here. Well, for 5, maybe we'll just do it in class. And then let's do a 6. 6 is a product rule. I have an x squared, and then it's arcsine x is a product. So do x equal to, f equal to x squared, g equal to arcsine x. So f prime is 2x. G prime, this is a 2x. G prime is 1 over square root of 1 minus x squared, right? So now this would become dy dx would become the product rule. Fig f times g. 2x sine inverse x plus gif 1 over this times x squared. So x squared over square root of 1 plus x squared. No, 1 minus x squared. Okay, so that's what you have. You can, do common denominator, but there's nothing much you can simplify. So this is the answer. Last part of 3.7 is an application. So this application is something that might show up later in chapter 4. So let's look at it. A building that is 225 feet long casts a shadow of various length when an angle of the elevation to the sun is alpha. So let's draw a picture. This is a building, it's really, really tall. 225 feet. And then if the angle of elevation to the sun, that means when you look at the sun, when the sun comes down, and angle of elevation, this is theta, these would be the shadow, right? So this is the shadow. And then the length of the shadow is x. So when the angle of elevation changes, then the length will change. So how can I relate theta, x, m, the height of the building? Relative to theta, this is opposite, and relative to theta, this is adjacent. So I can establish a ratio of tangent theta is equal to 225 over x, right? But I want so this is good enough, but I can also do cotangent theta equal to x over 225, right? So which one should I use? I think this one is easier because x is in the numerator. So I'll pick this, and so to relate this, and I'll say, okay, from here, I would say theta is what? That relate theta with the length of x. So theta would be arc cosine x over 225. Okay, so this is the function that relate theta with x. And when I say theta, this has to be in radian. Okay, this is a radian. Find d theta dx when x is 272. So I want to do the derivative of this respect to x. So this, if you use this, it's harder to do. So cotangent when x is in the top is easier. So d theta dx would equal to doing a derivative of cotangent inverse x over 225. So this is a composite function. Outside is cotangent, inside is x over 225 because it's not exactly x. So we'll do the outside first, which is cotangent. What is the formula for cotangent? Let's look at the last page. They're kind of difficult. So cotangent is -1 over 1 plus x squared. So this is the x that we talked about. We just say that this is inside, so it's -1 over 1 plus x over 225, the whole thing square. And then I'll do a derivative of the inside because of the chain rule, x over 225. X over 225 means 1 over 225 times x, so that would be equal to -1 over 1 plus x over 225 square times 1 over 225. So I can multiply this 1 over 225 in both of these. Like they can multiply it across. But this, so we have to simplify this fraction, this complex fraction. So I should multiply 225 square top and bottom to clean this 225 out, right? So we would have 225 square over 225 square plus x square times 1 over 225. So this would cancel one of them, so it would become, negative. Okay, negative 225 over 225 square plus x square times, and that's the answer for the derivative. At x equal to 272, you will plug in. Let's do it here. F of 227. So 227, that means negative 225 over 225 square plus 227 square. So put in the calculator, that would equal to negative 225 divided by 225 square plus 227 square. Negative point 0.0022. So the angles in radians will be changing at negative 0.022 per feet. Radian per feet. Okay, so it's a dy dx f prime. It should be f prime. So that's how you do this question.